Guys and gals, welcome to Mr. Hall's class. I'm glad that you decided to advance your careers and learn more about electricity. So we're going to be doing just a few things in today's lesson, and we're going to be learning about series circuits. We're going to be learning about parallel circuits and how to solve equations in a parallel circuit. So first off, we want to identify on the difference between a series and a parallel circuit. Now, every circuit has to have a power source. In our example today, we're going to use is a battery, and this battery is going to be 9 volts, and it has a positive and a negative terminal, and it also has to have a path to flow through. So we have wires that go over to a light, and then the light goes back over to our positive terminal. Now, this is called a series circuit, and the reason that this is a series circuit is because there is only one way that electricity can flow. It can only flow through this light and then back to the positive terminal. There's no other way, there's no other direction, no other avenue it can take. So this is why this is called a series circuit. Now, in a series circuit, you can add lights and so forth in your series circuit. You can add other resistors, and you can add other electrical components in here. Let's take lights for example, and it will still work in a series circuit. But if one light bulb goes bad, the whole circuit is shut down. So if this light bulb burns out, it kills this light too, because there's only one way for electricity to flow, and it will flow and it will stop here if this light's bad, and which will not allow this one to light up either. So this is called a series circuit. So the difference between series and parallel are this: a parallel circuit has multiple avenues in which electricity can flow through. We'll add another light to our circuit, and this can keep going on and on and on. But this is called a parallel circuit. So we can keep adding lights or resistors or whatever it may be in this circuit, and this is called a parallel circuit because the electricity can flow through this light and go to your positive terminal. It can flow through this light and go to your positive terminal, and it can also flow through your last one. So any time that one of these lights burns out, it really doesn't matter, because electricity, if this light burns out, electricity can still flow through here. This light will still burn, and it has a completed path. If you go to this last light, electricity can flow through here. Electrons can flow through this light and go to your positive source. So there's nothing stopping it from not working when you're doing a parallel circuit. All right. So inside this parallel circuit, there's some things that we're going to learn about, and this is something called Ohm's law. In order to solve equations, in order to solve any equations in a series or parallel circuit, Ohm's law is always applied. Now, first thing we're going to be talking about is E, is represented by E. That's called voltage, all right, or electromotive force is what voltage is. And so, in a parallel circuit, and this is something that you need to make sure you put in your notes, you need to make sure that you understand that voltage never changes in a parallel circuit. Voltage always stays the same, and no matter how many different parallels you get, circuit lights you have down through here, voltage will always stay the same on this. If you take an electrical meter, because this is how you read voltage, is through a meter. Electricity is invisible. Whether it's 1,000 volts or 9 volts, it does not matter. You cannot see electricity, so you got to use an instrument, and this is called a multimeter. You got to use an instrument in order to read electricity. So we decided that voltage never changes. We discussed that, and so if we took our electrical meter and we read from negative to positive, we would read 9 volts on our electrical meter. At any point along this problem, at any point we put as long as we put it between positive and negative, we'll always read 9 volts. So if we put it here and here, our reading would be 9 volts. If we put it from here to here, our reading would be 9 volts. And even if we put it from this point to this point, our reading would still be 9 volts, because voltage does not change in a parallel circuit. But the key to reading voltage with a meter in a circuit is you have to make sure that you're going from negative to positive. You got to have 2 different potentials here. So if you go from negative to negative, you're going to read 0. Even though there's 9 volts on your circuit, you're still going to read 0 if you go from negative to negative. If you go from positive to positive and try to read voltage, you will read 0. Even though voltage is there, yeah, but what is reading is reading the difference between the positive and the negative. So make sure whenever you're using a meter, whenever we're troubleshooting these circuits, make sure that you are going between negative and positive. And that's the same in an AC circuit inside your house or a factory or industry, and it's the same in a DC circuit. You must go between a negative and a positive, or hot and neutral, in order to read voltage. So make sure you keep that in mind. And so parallel voltage stays the same. And make sure that whenever you're reading voltage, you read it between negative and positive. So keep that in mind as you're going through these problems. So we learned what voltage was. All right. Now I here represents current. All right. Current is the flow of electrons, and so electrons flow through this circuit, and voltage is what pushes the electrons through the circuit. Okay. So voltage pushes the electrons through. It's the flow. Current is the flow of electrons. In Ohm's law, they represent this by I. So you need to make sure you put in your notes. You need to make sure you write down that I in Ohm's law represents current. Current is amps or amperes. Make sure you have that in your notes. Current is I in Ohm's law. And the last thing we're going to be learning about in Ohm's law is called resistance. Resistance is what kind of holds back, kind of restricts the flow of electrons. That's what a resistance is. And with the multimeter that you have and what's represented right here, will read voltage, it'll read amps, and it'll read resistance also. So as we're working through these problems, these equations, we're going to learn how to use Ohm's law and how does it apply to our circuit here. And you also be tested over these Ohm's law equations and how to solve them. So if we're trying to figure out if we did not know what voltage was, then we would use this Ohm's law table, this formula, in order to find voltage. And what we do here, voltage is determined. You put E, voltage is determined by whatever the resistance is multiplied by the current. So E equals I times R. Okay? So our current times our resistance. So if we did not know what our power, how many volts it was, but we did know that we had 10 amps, and we knew that we had 2 ohms of resistance. And another thing that we need to discuss and make sure that you put in your notes whenever you talk about resistance, is also known as ohms, or it has the Greek omega sign, which looks like this right here. That represents ohms. Okay, so we have 10 amps, and we had 2 ohms. So in order to find out what our voltage is here in this equation, we take I, which is amps, so we take 10 multiplied by 2 times 2 equals 10 times 2 equals 20. So 20 would be our volts. 20 would be our voltage. 20 would be what we're looking for to solve this electrical equation. All right? So, and we use the formula E equals I times R in order to find voltage. Now, if this one's 20, then all the rest of it would be 20 also, because because voltage does not change in a parallel circuit. All right, so next thing we're going to find, teach you how to find is current in this situation. So if we didn't know how many amps there was, if we didn't know our current, but we knew our voltage, so we'll say our voltage is 40. We'll pretend like our voltage is 40. We have 40 volts. We know it's the same all the way through. So we have 40 volts. Our equation begins to change because now we know our voltage and we know our resistance and we're looking for our amps. So to find this formula is I equals E divided by R. All right, so in this parallel circuit, our voltage is 40. So we got 40 divided by 2 equals 20. So our amps would be 20 amps. And we found that using Ohm's law. All right, that's how we determine on what our amps is. All right, and our last thing we want to discuss is resistance in a parallel circuit. All right, so resistance is about the same way. So if we know our voltage, and say, for example, here our voltage would be, we'll say our voltage is 30, and we know that our amps is 10 amps. All right, and so we use this formula. What we're trying to find is R. So what you would do, you would cover up R. So it's E divided by I equals R. All right, so R equals E divided by I. All right, so in this case, we have our voltage is 30, and we have 30 divided by 10, and 30 divided by 10 is 3, and so we 3 ohms. That's how we determine our ohms. That's how we determine in this situation. Now, I want to begin just to review with you real fast on what we have learned already. All right, so we learned the difference between series circuits and parallel circuits. So series circuits only has one path that electrons can flow through, and parallel circuits has multiple places that electricity can flow. And also what we determined was that in a parallel circuit, voltage stays the same. It does not change. And we want to make sure that we emphasize that to you. Voltage does not change in a parallel circuit. And then we also learned some terminology, and we used a formula called Ohm's law to answer these equations. And so Ohm's law was E over I times R. That counts our voltage. So anytime that we're trying to solve an equation here, whichever one we're trying to solve, we just cover it up. So if we wanted to know what the voltage is, we just put your hand over the E, and it's I times R. If you want to know what your current is, you just cover up the I, and it's E divided by R. If you want to know what your resistance is, you cover up the resistance, you cover up the R, and it's E divided by I. And so you use this formula in order to solve your parallel circuit. And the last thing that we talked about today was what this symbol represented. This omega sign, this Greek omega sign, represents a resistance or ohms. All right. So if you see anything with ohms, resistance, or you see omega sign, then it represents resistance. And I appreciate you listening. I appreciate you tuning in and being engaged in this class. And as we get into this, we're going to begin to learn more about series circuits, parallel, and then we're going to get into combination circuits and how that applies. We appreciate you, class, and we'll see you back again next week. Thank you.